Hello and welcome to assignment 5. We only have one goal in this entire assignment. There is a new word that we want to talk about and it's called acceleration. And by the end of this video, if you understand this word and if you can solve assignment 5, you're in good shape. So what is acceleration? What is this new word? Well, you might have heard this word when somebody is driving a car that they have an accelerator. So when they press on the gas, the car speeds up. And that's what we usually mean when we say the word acceleration. But in physics, we have a more refined definition of what an acceleration is. Um, how we define acceleration in physics is not that when the car speeds up, but also when it slows down. So anytime you change the speed of the car is basically an acceleration has happened. So what do I mean by that? So for example, if you look at this car, right, and this is moving at like a constant speed right now, slowly and nicely. But nobody moves slowly and nicely, especially not in Boston. So given that you could be in a traffic, you could be like stopping, speeding up, slowing down, depending on the speed limit on the road. So this car can go fast and can go slow, or it can also go backward or forward as well. Or it could also take turns and move in a circle or something like that as well. So nobody usually goes at a constant speed in a straight line. That's an ideal condition. So that's why we need another term. We need another physical quantity to describe when things change their speed or when they change their direction. So again, if you speed up or slow down, or if you change your direction, these are the three ways you can have an acceleration. So let's go ahead and write this down, okay? So what is an acceleration? Basically, when an object speeds up, or slows down, or changes direction. We say the acceleration has happened. That's how we say that there's an acceleration. But so if you're changing the speed or the direction, so a simple way to say that is if you change the velocity, that's one way to say that acceleration has happened. So a very beautiful, simple definition of acceleration is it is a rate of change of velocity. So at what rate is the velocity changing, basically, is what acceleration is all about. And how do you give this? Well, you give this by A for acceleration is equal to change in velocity divided by change in time. That's how you find it mathematically. We introduced a new symbol here, delta, this triangle. This is called delta. And what it means is basically change in. So instead of writing change in, I can just write delta V divided by delta T. Another simple way to write the same thing will be, so what do you mean by change in velocity? Well, you had a final velocity and you must have started from an initial velocity. So final velocity minus initial velocity divided by time. That's what acceleration is. So to simplify this further, in physics we love being lazy. So instead of writing final velocity every time, I'll just write a V, and for initial velocity I'll write a U, and for time I will write a T. So what this makes this equation as is acceleration is equal to V minus U divided by T. And guys, this is not anything new. It's the exact same thing as this one. How do you find the change in velocity? Well, if you had $10 and now you have $15, how much has your money changed? Well, it's changed by $5. How do you find that? You subtract 10 out of the 15. So final, you take the initial out of the final. Same thing I'm doing in the velocity. I have the final velocity and I subtract the initial one out of it to see how much it has changed. And that's what delta V means, or V minus U means, and T for time, whatever time it took for the change. So acceleration is just the rate at which the velocity changes, and the way to find that mathematically is this way. And we will do an example and this will make more sense. So hold on. How do I give the units? For example, when you say speed, right, you say meter per second. For distance and displacement, I knew meter was a unit. Speed, it's meter per second. Or even for velocity, this is the same. For velocity or for speed, it's meter per second. For acceleration, the unit is meter per second square. And the reason there is a square is because you're dividing velocity by time. Remember, in this equation, so for acceleration, so velocity is already meter per second, and you're dividing that by another second. And so these seconds combined together, they become a square, meter per second square. So that's the unit for acceleration. So anytime you write the acceleration is 4, you don't just say 4, it's 4 meter per second square. That's how you write the acceleration. The way you write speed is 4 meter per second. This is the way you express acceleration. This is the way you express velocity or speed. Okay, so I understand what acceleration is, hopefully, that anytime the velocity changes, and by velocity changes means either the speed goes up or down, or the speed remains the same but the direction change. That's how I know that there's an acceleration. So you could totally be moving on a circular track, for example, with a car and have the same speed. The speed of the car is not changing as you're going around the circular track, but your velocity is still changing because every moment you're changing your direction. So even if you just change the direction, you say that there is an acceleration. Okay, all right, let's do an example. This will make more sense once we have an example down. How do I do this example? All right, so let's just say initially at time t equal to 0, your time t equal to 0, your speed was 0 meter per second. You were not moving. And after a while, I see maybe time t equal to 2 seconds, you have a velocity of 4 meter per second. Okay. So my question is, what is the acceleration in this case? Well, I remember acceleration is nothing but final velocity minus the initial velocity divided by the time it took for that change. So in this case, the final velocity is 4. So 4 initial velocity was 0 because that's where I started from. So 4 minus 0, and you divide the whole thing by the time it took. So it went from 0 to 2. So it took 2 seconds for this change. And that gives me 4 divided by 2, and that's 2, very careful here, meter per second square. That will be my acceleration. Very plain, very simple, nothing too difficult. But now that you have figured out that the acceleration is 2 meters per second square, you don't know nothing about the acceleration. You just put some number in an equation, you found a number out. But what does it really mean to have an acceleration of 2 meters per second square? We really need to ask that question in physics all the time. What does it mean to have this number? What does it mean to have this quantity? And that's how you learn this subject. Well, what it means to have an acceleration of 2 meters per second square is that as time goes on, your speed will increase by 2 every second. So for example, if time was 0 and your speed was 0, that's when you started with, when the time was 0. And at time t equal to 1 second, then your speed will be 2 meters per second because your speed increases by 2 every second. At time t equal to 2 seconds, your speed will be 4 meters per second. And if you see, that's what happened here. At time 2 seconds, the speed was 4. At time t equal to 3, the speed will be 6 meters per second. At time t equal to 4, the speed will be 8 meters per second. That's the power of physics. So once you know the acceleration, now you can predict the future. And if the car goes with the same acceleration, you can give me any time in the world, and I can tell you what the speed will be at that time, or what the velocity would be at that time. And I'm sorry that I use the speed and velocity language interchangeably, but when you're moving in a straight line, speed and velocity is pretty much the same. So that's why I will sometimes say speed, sometimes say velocity, but it means the same thing. So yeah, and this should help you do the extra credit question too on the assignment. So if your acceleration is given to you and somebody is asking you, for example, say that acceleration is 8 meter per second square, and I ask you what will be the speed of this person after 2 seconds if they started from 0. Well, every second you increase by 8. So 8 in after 1 second, after 2 seconds your speed will be 16. So that's what it means to have an acceleration. Your speed is increasing by this much every second. And we will see that you can sometimes have a negative acceleration too, and that will mean that your speed might be reducing at that point. But we'll talk about this in the next assignment. When can you have positive or negative? When it's speeding up, when it's speeding down. But for now, we'll just deal with positive acceleration. So it's just all usually speeding up. All right. Hopefully that should help you finish your assignment number 5. See you in assignment number 6.